In this video, we're going to create a maze generator. So you'll be able to come in here and click generate maze, and it'll make a different maze every single time. You can even change the size of the maze, so I'll just make it 11 and 11. And there we go. All of the source code for this is in the description below. To start off, we have two images, closed and open, for closed tiles and open tiles in our maze. Let's go ahead and we'll create two files, index.html and style.css. Let's jump into index.html. We'll come in here, we'll hit the exclamation mark in VS Code and hit enter. And that'll generate that. Let's link our CSS. So we'll hit enter and we'll say link and then style.css. Let's go ahead and preview this. So we're going to come in here, open with live server. This is an extension. If you go to extensions and you type live, it should be the first thing that appears as of the recording of this video. So coming back into there. Let's go ahead and we'll open with live. We'll right click and open with live server. If you're on a Mac, that's control click. Yeah, I'm bringing this over here. Okay, and then let's put that like that. Yeah, there we go. You know, the first thing I actually change is the background color. So let's come in here. We're going to style the body of the HTML. We'll do background color and we'll do, let's just do black. There we go. Perfect. Let's go to index.html. I'm thinking the controls are up at the top and then the maze will generate at the bottom. Let's create two divs and we'll open them up. For the first one, let's give this an ID of settings. And then this one, we're going to give an ID of container. First, let's go ahead and do a label for our maze generator. Now, because we did a dark background, there is actually text here. Look at that. It's right there. Let's dive into style.css. We're going to do color white. There we go. Let's dive back into our HTML. First, we're going to create an input field for the width. So this, we've got a label, which is this text right here. The value can go from anywhere between 5 and 200. And we're going to start out at 25. It's a type of number. And then also too, if you do this for and give the ID of the input, check this out. If you click here, it'll actually select like that. So we've done the width, which is left and right. Let's do height. So yeah, we've got our width and then our height inputs. We'll scroll down a little bit. We're going to create a button that when we click it, it's going to create a maze. And then we'll have another button for downloading the maze later once we get all that done. So our container is going to show a bunch of tiles here, but it's absolutely possible that the map might be bigger than the screen in either direction. So what we're going to do is we're going to come down here and create another div called maze display. Everything's going to be inside of here, and this is going to be potentially bigger than the screen, but this will remain the size of the screen. And our CSS will make it so that you can scroll this view. Let's dive into style.css. First, let's style our settings to have a different background color and then just a little bit of padding for to make it look a little bit better. By default, browsers add margin to the page. It's hard to see, but you might see this little space here. So in the body, we'll just say margin 0, and that will get rid of that. Perfect. Everything's actually set up to start doing our JavaScript. So let's come in here and let's dive into Explore. And then we're going to do maze.js. Our JavaScript is going to be broken up into 5 different functions. All of the global variables that we have, which we can set up here, actually generating the maze, which will be here, displaying the maze to the page, and then getting a download file of the maze, as well as any helper functions that we'll code here. First, we'll keep a reference of our input fields. Next, we're going to have constants for how big every single tile is in pixels, as well as I like to do open and closed here, because what you can do later in your code is instead of saying if tile equals 1 or something weird like that, you can say if tile equals open. Also, for easy access, we'll come in and we'll keep track of the image names as well. So we'll come in here, we'll start out with an empty maze that has nothing inside of it. Our goal right now is to just get the maze to display on the page with all empty tiles. That way it'll make it easier for us to know that our rendering is actually working and stuff before we get into the maze generation. So let's actually start by creating just a maze that has everything that's blank. When the user hits the create maze button, it's going to call this function. So you can think of functions like blocks of code. So when I click this button, run this code. First, we're going to come in here and get the numbers that are inside of here. Any input that you get is text. I mean, we did type number earlier, but I can still type text inside of here. So because of that, these are actually strings. These are not a number type. These are not integers. So what we need to do is we need to run parseInt on the input value that we get from both of these so that they're converted into numbers. Next, we need to create a empty two-dimensional array that we can put all of our tile data into. I think this is a great opportunity to create a helper function for this. Let's scroll to the way bottom down to helper functions. Let's create a nice function for just creating a 2D array, taking in a width and height of, how much you want it left and right and up and down, and then what we should fill that array with. Declare a array to start with. We'll come in here and we loop through Y first, then we'll loop through X here later. Let's create each row. We will then loop through X. I know that sounds kind of backwards, but we want to loop through Y first and then X. So basically you have a bunch of rows here, and then each row has a bunch of items inside of it. So the code is first going through each row, and then inside of those rows, right, for each row, it's going right through each one of these items, and then it goes to the next one, right? And it goes 1, 2, 3, 4, and so on and so forth. So we will loop through each row, and then we're going to push whatever we want to fill it with. So let's say we want to do a 2D array and we want it all filled with 7s, right? So this will fill every single one of these with 7s. Let's add each row to our original array here, and then we're going to return the array here. This is a nice function you can use in other projects that you're using if you ever need to. Let's go ahead and scroll up to the second section, the maze generation, and we'll continue on from that point. Let's come in here and we're going to create our 2D array. We're going to have it be this size, right, the width and height. And then we're also going to fill it with closed blocks. Now this is where, again, that constant that we did earlier really comes in handy, because otherwise we can just say 0, but that's not really clear what it's doing. We're filling it with closed blocks. All of our maze generation logic is going to go here. We're going to come back to that, and then we're going to render our maze to the screen after everything's done. So let's go ahead and we'll draw our maze with solid blocks. We're going to get a reference to that maze display element in our HTML. Again, that's if you go to index.html, it's this one inside of here. We're going to put all of our blocks inside of there. Go back to maze.js. Any previous maze that was already drawn to the screen, we're going to go ahead and get rid of here. We're going to draw everything in the same direction that we talked about earlier. So we're going to go row by row. So we're looping through Y first. To get that maze is an array of rows, and we're getting how many rows is inside of it. Then we go through each row and we get for that row, for maze Y, we're going to get however many items are inside of each row. We need to determine whether it's a closed or open image, so let's go ahead and just declare a variable. We're also going to get the tile at the current position that we're at. Then, if the tile is closed, then it's going to be the closed tile image. Otherwise, if it's open, it's going to be the open tile image. If the tile is closed, we're going to do the closed tile image. If the tile is not closed, then we're going to do the open tile image. And this is, again, where using a constant makes it a lot kind of easier, because now it's like, oh, if the tile is closed, we set it to the closed tile image. Instead of having to do something like this, right? It's, okay, what does 0 mean, right? In testing this, there's a couple ways we could do this. Next, we're going to create a new image element for that tile. We're going to set the source of that image to the image name. And then we're going to append the child to the container. Basically, this code right here is going to create this that you see. So we're creating an image element, and then we're going to set the source to whatever the image name is, and then we're going to add that to our web page. And then finally, so go ahead and go after this, and we're going to add a BR element to that. That'll just say, hey, go to the next line. Now, in testing this, I actually tried to do container.innerHTML plus equals something. And that actually was really, really slow. This is a lot faster, and that's the only reason why I did it this way. Another version of this had a HTML canvas that it rendered, and that was actually very fast, but scrolling wasn't necessarily supported on that. So I found that this is probably, for the sake of this video, this is probably a really good way to go about this. Finally, we need to actually link this JavaScript to our HTML. So let's go ahead and we'll dive into index.html. We'll go, I like to put it after the body, so we'll go right after there. And you can just type script. If you even go there, it'll just do that. So script source, and then we want to put maze.js inside of here. There we go, moving my head out of the way. We're going to test this, so let's dive in and go ahead and hit the create maze button. The image is missing, let's fix that real quick. Let's go ahead and dive into maze.js. Go ahead and scroll up to the way top. I did different image names for this. You might have already picked that up, but let's do close. So I'm in maze.js, the JavaScript file. We're going to do close.png for the closed tile image. And we're going to do open.png for the open tile image. Let's test this. We'll dive into, let's go ahead and click the create maze again. Now, what you might notice is that basically it actually does do 25 for each one, but it's limiting it to the size of the web page. So let's go ahead and we'll change that. Let's go into style.css. Let's come in here. We're going to style our maze display ID. And one really quick solution to this is you can just set a really massive width to this element, and it'll actually fix that. Now, another thing is if you scroll on the web page, have a look. It kind of looks a little bit broken, right? If you scroll horizontally, and if you scroll vertically, vertically is fine, but then if you scroll like that, it's kind of broken. So let's come in here, we'll style our container. On our container, go ahead and do overflow scroll, and basically that'll add scrolling to this, and yeah, we're good to go. Now, another thing you can do is you can actually say auto instead, and this will only add scroll bars to it if it's big enough. So yeah, there we go. Yeah, we're able to scroll. Now we're ready to sort of start working with our maze. So let's dive into maze.js. Go ahead and find your create maze function in the maze creation, and we're going to go to this section right here. So right before we draw the maze, we're going to do all of our maze generation. We're going to use a depth first search in order to do this. Wikipedia has an amazing article on maze generation, and they even have like little videos and stuff that you can see. So the one we're going to do is a depth first search. It's one of the first ones on the actual page. I'm going to click it and I'm just going to run you through that, but this will be also in the link in the description below as well. So yeah, if you kind of see what it's doing is it's filling everything, and then once it runs out of ways to go, it backtracks. That's why if you see that blue, it's like, oh, okay, I'm moving. But every time that you see the blue, it's basically moving back. Yeah, so now it's like filling in all the gaps here. And there we go. And it has one more tile to do, and it's done. We're going to code this. But if you go on this page, there are several different ones that are really interesting. Anyway, let's go ahead and dive back into our code. Anyway, so diving back into our code, find where it says create maze, and then we under the maze generation section of maze.js, and we're going to get rid of this part right here. Maze generation is going to need a lot of randomness, and we need a way to get random numbers. So let's go ahead and we'll make a helper function. Let's scroll down all the way to the bottom, and we're going to add this function right here, random int. So what it does, math.random gives you a number between 0 all the way to 1. So it'll give you a number that's like 0.2 or 0.5 or something along those lines. So what you can do is if you want a number between 0 and 10, you can just multiply this by 10. And then bam, now you have like 5. But this number often has a bunch of different decimals associated with it. What this does is this basically gets a range. So we take away the minimum first, right? So let's say that we want a number between 1 and 5. So basically our range is going to be 4. So we find a number between 0 and 4, right? Maybe we get 2. And then we add the minimum back, and bam, now we have 3. Then realistically, you're always going to have generally some number that's like has a decimal place or something before that. And we want an integer. So we just get the floor of that. When you get the floor, you round down. So we just throw away this decimal place, and now you have 3. So now that we have this, let's go ahead and we're going to go up to the create maze function again. First, we need to figure out where we're even starting with this. So we're going to get a random number starting on the X position and then also the Y position as well. We want to have a border around the entire maze. So we're going to start at 1 is the smallest one. So for the second one, and then we're going to do width -1. This will make sure that there's a border around there so that we never start right on the edge of the maze. Once we figured out where we want to start, we're going to start digging from that spot. So again, we have an entire maze here. Everything is solid, and we're going to start at one of those tiles, and we're just going to start digging the maze, kind of as you saw in that animation earlier. Let's come over here to line 39. We're going to create a couple functions here. First, we're going to have a function that digs around a current tile. To illustrate this point, let's say that we start here. It's going to check here, 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 and here to see if we need to dig. It's going to pick one of these directions randomly first to start with. So let's say that we dig in this direction, and then at some point it's going to dig these other ones, but we're going to recursively call it. So it's going to call the dig around function again. We can't go to the right again because we've already digged that way, and we can't go left because that would dig off the map. So it's going to pick either one of these randomly, and it's probably going to pick this way. Okay, so we've digged that much. Now we're going to check each one of the directions. Okay, the only one that's valid is this one. In this case now, it's going to check each one of the directions again. It's not going to be able to dig that way. It's not going to be able to dig that way, and it can't dig back. So it's going to come in here and it's going to dig this way. And so on and so forth. Now, one issue I want to make aware is that this is a 8 by 8 grid of tiles. So these are even numbers. The problem is that, check this out, we can actually dig outside past this, and then we can dig over here. And notice how it's digging on the edge of the maze here. This is one of the issues with using tiles as walls if you have an even number. This is actually one of the issues of generating a maze and using tiles as the walls. But for the sake of this video, let's leave it, and we'll just make mazes that have an odd number, just so we can kind of demonstrate and learn the concept. Because of that, this dig around function right here is going to try to dig all the neighbors. And then the dig to is going to take, and it's going to check to see if these are open. And if it is, it's going to dig to that. It's always going to go by 2 tiles. So let's say that we're here. It's going to go 2 tiles over here. And then it's also going to set the midpoint as well. Start off by setting the current tile to be open. Then let's go ahead and get each one of the neighbors. So this is left because we're doing x minus 2, right, x plus 2, right, y minus 2, and y plus 2. So we should shuffle these each time just so that it doesn't pick left every single time. So let's create another function for that. Let's go ahead and scroll down to our helper functions. Let's come over here and we're going to do shuffle array. We're going to shuffle an array using the Fisher-Yates sorting algorithm. Basically, imagine if you have a deck of cards and you just go through the deck and swap each card with another card. So basically, we're going to go through, we're going to start with this first one, and we're going to swap this randomly with this guy. And we'll go and we'll do that. And then it goes to the second one, and maybe it swaps this one randomly with this one. And then we go to this one, and maybe this swaps with itself. So it is possible that some of these may not get swapped. And then it goes to this one and it swaps with maybe this one again. And the end result is that every single one of these will have a chance to swap. And some of these will actually swap more than once. So first, let's go ahead and we'll get a copy of the array. So we're going to create a whole new array, and then we're just going to add all the items into that array. Then we're going to go through each one of them. So every single time we're going to get a random spot to swap with. and then we're going to perform the swap. Now, we need a temporary location for us to take a card out of the deck, put it in there, and then, set that spot to the other one, and then we set the spot to the temporary memory. So when you perform, basically when you perform a swap of two things, this is how you can do it without losing one or the other. Super important at the very end. Let's actually return all the work that we did, and we'll go from there. We'll scroll up to where we were doing our neighbors earlier. And let's come in here and we'll just shuffle all the neighbors around. You can use this function to randomize any array in JavaScript. Let's come in here and let's loop through each one of the neighbors in our new shuffled order. And we're going to try to dig to each location. Let's go into the dig-to function. So the dig-to function is going to try to dig to a destination from a certain location. So let's say that we have a grid here, right? We're going from this tile and we're going to dig to this tile. It always skips one. So we're going to come in here, we're going to try to dig to this tile. If the destination tile and also the midpoint are both closed, we're going to then dig to those tiles, and this will have already been dug to. Then from the destination, we're going to call the dig around function again. So the destination's then going to try to dig in all directions from there. We have the destination and the from tiles, but there's a tile in between them. Let's find that by getting the midpoint. We're also going to check to see whether the tile is even on the map to begin with. If it's not, we're just going to do return, and that will, we don't want to go anything further. So this will just exit the function and not run any code after this. Now, if we haven't already dug in this direction, so we're getting basically we're saying, okay, get the destination point, get the midpoint, right? And then check if the destination is closed and check if the midpoint is closed. This is where doing constants is awesome because we don't want to do something like that. That's really confusing. It's like, what does 0 mean? But we can come in here and we can say, oh, his destination is it a closed tile? If this is the case, then we're going to set the destination to open. We're also going to set the midpoint to open. And then we're just going to try to dig all the neighbors of the new spot. Now, what's really important about this is that let's say that you're looping through this whole loop here, right? And, oh, okay, I'm going to dig to this neighbor. So the thing is that let's say that we successfully dig to that. It's going to do this dig around, and it's going to wait to do all the other neighbors that we did previously. So it's going to dig in that new spot, and it's going to try to dig those neighbors first. This is sort of the recursive part of it. These two functions are going to basically play ping pong, and they're going to go back and forth. Finally, we need to do the is within map, and I forgot to do the arguments here. So let's do x and y. And then we're going to check and see if we're within the map. Now, we're going to check to make sure that the point is not too much to the left, that it's not too much up, that it's not too much to the right, and it's not too much down, that it's like within the map in all four of those directions. So now that we did all of this, let's go ahead and we'll scroll up to the way top to this create maze function. So yeah, we're just going to start by digging all the neighbors of the first location, and that's where everything will start. This is actually ready to test. Let's go ahead and we'll do create maze. And there we go. Well, we've got a maze. Very good. Now you might notice the CSS for the maze, there's these little lines here. So let's go ahead and edit the CSS real quick. Go into style.css. Go into maze let me move my head here. Go to maze display. And what we're going to do is we're going to say line height, and we'll just say 0. And that will fix everything. So now, yeah, we have now created a maze. Perfect. So now what we need to do is we need to create entrances and exits out of our maze. So come into maze.js up at the top, and let's go ahead and we're going to create another function for that. So let's go right after this is within map. Let's come in here and we're going to make a new function called create egresses, right? So the entrance and the exit, the two egresses that there are to the map. Let's declare variables for the entrance and exit. In testing this, we need a way to check and see whether we want to do the exits on the top and bottom, or whether we want to do them on left and right. If you do left and top, it's possible that the maze becomes really easy to solve. And if you do them on like the same side, like if you do them both on the bottom, it may potentially be really easy to solve. So I think a good way to do this is to put the exit and entrance on the left and right, and then up and down. We need a function that can just sort of flip a coin. So let's go ahead and we'll scroll down to the bottom into our helper functions and find your random int function. Let's come in here. We're gonna create a random coin function. This is going to return true or false. It's going to return true half the time and false half the time. So have a look at this. Every time that we run math.random, it gives us a number between 0 and 1. So what we can do is we can actually run the following. So we're checking to see if that random number is greater than 0.5. And essentially you start getting a coin toss. You start getting whether it's, it could be true or false again or true or whichever. So yeah, this function is basically doing that. Let's come up to the top here and we're going to go to our create egresses function. We're going to flip a coin to see whether we should do left or right or up or down. So let's say that it's true. We'll put the entrance and exit to the left. Now, so in order to do it to the left, x is going to be 0 because it's going to be right over on this side. And then the x on the right is going to be all the whole maze length all the way to the right. Then, in order to get the thing that's going to be random, though, is going to be the y coordinate. So on the left side, we're going to somewhere up and down, we're going to put that thing there. Same thing for the exit. Come in here and also do the following for the up and down. So it's just in the opposite order. The y is 0 in this case, and then the y is all the way down, right? The maze length minus 1. Now, one other thing to note is when you're writing this, just be careful about x and y. One time I mistaked and I put an x where a y was supposed to be, and I looked for it for 3 days. So just be really cautious when you're doing x and y here. Finally, at the very end, we're going to set the entrance to open, and we're also going to set the exit to open. There's actually a flaw with this. We're going to come back to this here in a second, but let's go ahead and scroll up a little bit. And we're going to go to our create maze function, and we're going to do it right after we dig around. We're going to create the egresses, and we'll go from there. Now let's come in here. We're going to run it. So let's go ahead and create maze. And already check this out. There's actually a huge issue there's actually 2 issues with this. One is that it could potentially start on a even number. So potentially, kind of what we were discussing earlier, it could potentially dig into the top. This is the problem with doing tiles as walls. So we'll fix that. And then the other thing too, to show you here real quick. Yeah, here's another example of this. Check out the exit here on the right. Right? It created it, where there's not actually a tile here. One way that we can do this is we can ensure that the starting position is odd numbers, and also ensure that the egresses are odd numbers. Go into the way bottom of the entire file. We're going to come in here, we're going to take in a function that sets something to odd. We're going to check to see that it is odd already. And then if it is, then we're just going to use the number. Otherwise, we're going to use the number plus 1. So if we pass in a 0, then it's going to become a 1. If you pass in a 1, it's going to stay as a 1. It's always just going to add 1 to it. It's always just going to add 1 to it. Go ahead and scroll up again to the create maze function. And let's come in here and let's just ensure that the odd numbers are like so. Let's come in here, we'll generate the maze. So yeah, every single time that you generate the maze, it now does not go on the edges. But again, one issue is if you set these to an even number, like 20, right? You create the maze and then it sort of, breaks that off, right? So for the sake of this video, we're just going to use odd numbers. And yeah, we'll create that and we'll go from there. Now, sometimes the egresses are not fixed yet. So let's go ahead and fix those. Find your create egresses function. And let's come in here and we're going to set, in the case of left and right, we're going to set the y coordinate, the one that we're actually changing, right, we're going to set it to odd. And then we're going to come in here, we're going to set this one to odd as well, right? So if we're moving it, if we're setting the entrance and exit up and down, it's going to randomly pick an X coordinate. We're just going to make sure that X coordinate is odd. And then every single time, go ahead and test it. Let's come in and we'll create maze. And every single time that you do this, you should have entrances and exits that actually have a maze. Brilliant. Give yourself a pat on the back. That is maze generation via a depth first search algorithm. Now, one thing you might notice is some solutions are easier than others, and that's actually kind of okay. In this case, for example, the solution kind of is all to the right, so you really don't need to move into the left of the maze really at all. But yeah, every single time we create the maze, it's going to give us another one. Now, the very last thing we need to do is hit that, have that download button so we can take these mazes and use them for something else if we so want to. So let's go ahead and we're going to find the download maze function. Basically, when you hit the download button, it's going to give you a text file of the maze. And so we need to create a string of data that we're going to put in the text file. Going from row to row, right, we're going to start with Y as we've done previously. Then inside of each row, we're going to loop through each item in that row. And then we're going to add the number, whatever that tile is, to the data. Finally, after every single row is done, we're going to do a new line after it so that it goes to the next row of text. Now, the thing is that we're not writing any server code or anything. This is just purely a web page code. But there is a way that you can actually create a download still by doing that. Files are blob data. So basically, we're just going to put a bunch of data inside of a blob, and then we're going to send that as a download to ourselves, essentially. In order to do that, we need to create a link of some sort, and then we're going to use JavaScript to basically click the link, and then we're going to remove that link from the page. We're going to have it create some kind of URL sort of synthetically, and it'll put the blob there. This is not putting it online for downloads or anything. This is just the actual web page itself is sort of making up a temporary URL that it can use to download the element. Let's name the file that they're going to download maze.txt. And then finally, we're going to add the link. We're going to click it. We're going to have JavaScript click it for us. And then we're going to remove the link from the page. Let's come in here and we'll test it. So come over here, create a maze, and then go ahead and hit the download button. Yeah, there we go. Let's click this. And there we go. We have a maze. Yeah, there we go. So I'll zoom on this a little bit. You can kind of see that every single one of the zeros represents where the maze is over here. And then every single one of the ones is like that. Now you might notice that it doesn't look square. And that's because of the font. Generally speaking, characters are a little bit thinner than they are taller. One final thing I want to mention, there is a slight bug in the code. When you flip the random coin for the left and right, this is in the create egress function. Just make sure that actually go ahead and get rid of these where it says 0 there and there. I told you earlier that one time I mixed up X and Y and it took 3 days to find it. I'm really grateful that this didn't take 3 days to find this error. I'm glad you actually saw that because it's so easy to mix up X and Y like that. But yeah, just go ahead and test it and yeah, it runs good. And then give it a different width. And then, yeah, every single time it does it. And that is maze generation in a nutshell. So thank you so much. I hope that this video has been beneficial for you. I will also, again, I'll include the Wikipedia link in the description below if you want to explore other maze generation algorithms. Another thing that we could potentially do is have the walls be sort of lines instead of tiles. And that would give a lot more flexibility to kind of, add things. So anyway, thank you so much. And I hope you have a good rest of your day.